With the H2C finally released, we have a little bit more information to help provide clarity on some of the questions we had in our previous video. You don't have to go back and look at that video, we'll cover it all right here. To get started, let's look at the multi-nozzle capabilities. Yes, the H2C can support 6 nozzles on the right hot end and 1 nozzle on the left hot end, all of it being fed by an AMS or multiple AMS units to the left and right hot end. So who is the H2C for? Well, with the capabilities of that right hot end being able to swap between 6 different nozzles, it really comes down to time and waste, which is truthfully what Bambu Lab has been marketing the H2C to be for from day one. So I ran this experiment to help illustrate the differences between the H2C and the H2D and the H2S. The top cube was printed with my H2D, but on a single nozzle. After 8.5 hours, I ended up with a bag of purge and a prime tower. The bottom cube was printed with the H2D, but it leveraged both the left and right nozzle. In that case, I ended up with 2.5 hour print and just a small amount of waste and the purge tower. This is a great way to illustrate for every material above and beyond the nozzle numbers on your printer how time and waste can multiply. The H2C can support different sized nozzles as far as a storage capability goes. In other words, I can have a 0.2, a 0.4, and a 0.6 stored internally, and the H2C is able to use those depending on how you slice the print. The H2C is not able to use different nozzle sizes during the same print, but it is able to use different nozzle types of the same size. In other words, a high flow alongside a hardened steel, as long as they are both, say, 0.4 millimeter size. This means you can dedicate a nozzle to TPU. However, you're really limited to TPU for AMS as a result of these nozzles being fed by the AMS system. So we haven't gained much ground on TPU use with the H2C over the H2D. That's a little unfortunate. I do quite a bit of printing with the softer TPUs. If you're interested in learning more about that, hit that subscribe button, as I have several videos coming up about the different types of TPU printing and how to print those with the Bambu Lab or other printers. Another point along the lines of the AMS, Bambu Lab hints at a track changer. Sounds like there might be a capability coming to where you could put an AMS that is normally locked into, say, the right hot end, and switch that over to the left hot end, or vice versa. This certainly would increase flexibility to allow you to put filament in whichever AMS you want, and the system can automatically adjust to using that filament. Next up is build volume. The H2C comes in slightly smaller than the H2D or H2S at 330 by 320 by 325 millimeters. This is a relatively small adjustment, but if you are concerned about the largest build volume possible, it may be a concern for you. A key note here is that the build plates for the H2D and the H2S will not be compatible with the H2C except for the cutting plate and the vision encoder. Next up, upgrade paths. Bambu Lab has confirmed there will be an upgrade path for the H2S and the H2D to get it to an H2C coming sometime in 2026. They still seem quite hesitant on offering this based on a complexity and a cost perspective. Will I be upgrading my H2D to an H2C? The jury's still out. What is the price point of the upgrade kit? I probably can't justify buying another printer at the cost of the H2C when my primary use cases are dual material printing or dual material plus TPU. If you have any 3D printers that you think would be great fits for dual material plus TPU, please let me know in the comments below. That's all we have for today. Hope you enjoyed the video, and we'll see you in the next one.